Here I'm going to look at some examples dealing with tangents to circles. I have about, I think there were 4 examples here. In this first one, it tells us that segment RS is a tangent segment, and it's tangent to circle Q, which helps us out with some information. Specifically, it's telling us that Q is the center, therefore when we look at segment PR, we know that segment PR is going to be a diameter. And we know that the tangent segment is intersecting at point R, therefore there's our one point on the circle, which then tells us that this angle right here is going to be a right angle because remember, a tangent segment or a tangent line is perpendicular to the one radius that it intersects. And we want to find the value of y. Well, y is the length of the diameter. But I do know that I have a right angle there, which is going to tell us that this triangle right here is a right triangle. And if I have a right triangle that I know the length of 2 sides, I can use the Pythagorean theorem. So I'm going to call 16 my a. There's my a squared plus my b is going to be the radius. So I'm going to put r in there, square that, and that's going to be equal to the c squared. That 20 is the length of segment QS. It might be a little deceiving on that. That 20 might look like it's the radius, but I meant it to be the length of segment QS. Now it's just a matter of going through and solving my equation. So 16 squared, it comes out to be 256 plus r squared equal to 400. Subtract my 256 from both sides and find out that r squared is equal to 144. Next thing I need to do is take the square root of both sides of my equation, find out that r equals, remember, take the square root of an equation, you got to take the plus or minus, so we're going to get plus or minus 12. Now looking for a length of a side of a triangle, the negative 12 doesn't make sense, therefore this piece right here is going to be 12, which means this one's 12. Add those together, we're going to find out that y is 24. And we have solved our first problem. Now in the second one, I want to know, is segment BC a tangent segment? And some of you will look at it and go, well, it looks like it. It looks like it's only intersecting at this one point right here, which might be the case, but don't go by what it looks like, remember? So what we can do is we can use the converse of the Pythagorean theorem, which says if the Pythagorean theorem works, that little equation, a squared plus b squared equal to c squared, then it is a right triangle. And if that triangle ABC comes out to be a right triangle, I know I'd have a right angle in this area. And if that's a right angle, then I know that segment BC has to be a tangent line because the tangent is perpendicular to the radius. So I'm going to try my Pythagorean theorem here. I'm going to let the 7, the radius, be my a. So I'm going to have a squared plus my b is going to be my 9, and then c is going to be the 7 plus 7, which is 14. And I probably shouldn't have done this. I'm going to take that out of there. I don't know if it's equal. I guess I could have left the equal sign there, and I'm going to go like this. Put a question mark there. Is it really equal? Well, now it's a matter of squaring numbers and adding. If I could actually square them, that would help. So I have 49 plus 81. Add those two numbers together, I'm going to get 130. And then when I square 14, I end up with 196. Well, those two things are definitely not equal. So to answer the question, is segment BC tangent to the circle? It is not. No. Now in this one, we want to figure out if segment WE is tangent to the circle. And some of you would look at this and say, well, there's not enough information because I only have 2 side lengths of my triangle. I've also seen some students use the Pythagorean theorem to find the length of this side. But if you're using the Pythagorean theorem to find the length of that side, you're already saying it's a right triangle, so that's not going to work. But what I am going to look at here is this fact. It tells me from D to the circle is 10, which would be the radius then. So then if I come here, from D to the circle, that should be 10. And I guess technically in this one, I probably should have had a little fact in here that we're working with circle D. That would have been an assumption that I was making, which probably would not be a good thing in some cases. So remember that this is working with circle D. And then we'll know that segment DW is a radius, and we'd be able to use that 10. And now I can use the Pythagorean theorem just like I did in the last one. So this time, I'm going to let 10 be my A, plus B is going to be 24. Are these things equal? Well, no, this is going to be 26 squared. So we have 100 plus 576. Add those two things together, and I end up with 676. If I square 26, that's 676. Those two things are equal, which tells us that, yes, it is going to be a tangent, because the Pythagorean theorem tells us it's a right triangle, which will tell us that we have our right angle there, and then we know that segment WE is going to be perpendicular to segment DW, which means it's a tangent segment. Now in this example, I want to find the values or calculate the values of x and of y. Specifically x it asks for in the problem, but in order to get x, I'm going to have to figure out y first. Now the first thing I'm going to look at is segment DF and segment DE. I see that those are tangent to circle S, therefore I know y is going to have to be 10 units long, because remember, tangent segments that share an endpoint are going to be congruent. And then I can look at segment DH, this whole one, and segment DG. Well, those are tangent to circle T, therefore those are going to have to be congruent. So what I'm going to do is I'm going to look at the length of the whole thing. So segment DG is going to be 10 plus y minus 5. Segment DH is going to be, well, the green 10. It's going to be 10 plus, oops, I should have put my y value in there. But anyway, segment DH is going to be 10 plus x plus 4, and we know that those are going to be equal. Now let me replace the 10 with y here. So I'm just going to put the little 10 there. So now I have 10 plus 10 minus 5. This is 15, equal to 14 plus x. Get rid of the 14, and we find out that our x value is 1. Just by using the theorem that says that tangent segments that share an endpoint are going to be congruent. And I use essentially two equations, one here, this one was pretty straightforward, and then I set this one up using the larger tangent segments. And then my last one, I want to find the perimeter of triangle HJK. And it gives me some information in the picture, and it gives me this little equation here. Now the first thing that I'm going to look at is, I see segment JM up here. It's a tangent segment because it's only touching the circle one time at point M, and I'm going to look here at segment JL. That's a tangent segment as well. Therefore, I'm going to know that that one's going to be 16 units long. The next one I work around and I go, well, segment HL is a tangent segment, so is segment HN. Therefore, they share an endpoint, therefore they're going to be equal in length. So I know that one. And now I look up here at this equation, and it tells me that the length of segment NK, which would be right here, is equal to the length of segment JL plus 29. Well, I know the length of segment JL. That's 29. I found that out earlier, or not 29, excuse me. I was looking at the 29 at the end of the equation. It's 16 plus the 29. So if I add those two things together, I'm going to end up with 47. So the length of segment, oops, not 47, I can't add right now. Let me try that one more time. Let's go with 45. So this is going to be 45 units long, which means then the length of segment KM is also going to be 45 units long because they are tangent segments that share an endpoint. Now I look at my triangle and I know the length of all the sides. All I need to do is add them together. I'm going to start at the top of my triangle. and work myself way around. I have the 16, I have the 45, 45, 18, another 18, and finally back to the top with the last 16. After I add all those together, I end up with a total of 158. I'm going to put units on there for the perimeter of my triangle. And that's going to conclude my examples dealing with tangents of circles.